In this problem, we're asked to classify the triangle LMN by its side lengths. In other words, is it equilateral, is it isosceles, is it scalene? And we need to figure out the lengths of the three sides in order to do that. And the way we're going to do that is we're going to use the Pythagorean theorem. And how am I going to do that? Well, I'm going to construct a couple of right triangles. Three of them, actually. So let's start by doing that. Let's make our right triangles, and I'll make them here. I've got one that's 2 units on that side. And let's see, how many units is this going to be? I'm going to have to count. So I've got one in red, and I'm going to have another one in black here. Actually, let's just start with the red one, I think. Might make our lives a little bit easier. And so for this red one, I've got one leg is 2 units, and the other leg is 1, 2, 3, 4, 5, 6, 7 units. All right, so let's start with the red one. So for the red, that's going to be a squared plus b squared equals c squared. And what do I have? I said I had 2 units plus, I believe I said 7 units. It's going to equal c squared. I've got 4 plus 49 equals c squared. And I've got 53 equals c squared. And this is for my red one. And I'm going to take the square root of both of these, and I'm going to leave this as an irrational. I'm going to say that c equals the square root of 53. And the reason I'm doing this is because I don't need any more information than that. I'm trying to figure out what type of triangle this is. So that's all I need. If I get 3 square roots of 53, I will know that it is equilateral. If I get 2 square roots of 53, it's isosceles. And if I get 3 different values, I know it's going to be scalene. All right, let's take a look at our next triangle. I'll do this one in black, and I'm going to do it right here. It looks like I'm going to be at the same point this way. So here we go. And I'm going to, pardon me, put a line there. And as you can see, I've got another right triangle. And let's see what our units are here for this black one. I believe, let's count, that's 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Okay, so for the black one, and I'm going to slide this up at this point, for this black triangle, it looks like a squared plus b squared equals c squared, and what I end up getting here is 5 squared plus 5 squared equals c squared. And this would, of course, be 25 plus 25 equals c squared. 50 equals c squared, and taking the square root of both, I'm going to leave this as an irrational. C equals the square root of 50. Okay, so thus far, I know that this side of this triangle is the square root of 50. This one is the square root of 53. And now I just have to do this last triangle, which I'll do in green. Pardon me. And let's see, it's going to be right to here. And going over this way. And from that, I can see that I've got a triangle that is, let's see, I'm going to slide this such that we can see it. This is going to be for my green one. And what have we got? A squared plus b squared equals c squared. And this is 2 units plus 1, 2, 3, 4, 5, 6, 7 units equals c squared. And as you can see, I've got some familiar numbers here. And that's 53 equals c squared. And taking the square root of both of these, c equals the square root of 53. So now for my green triangle, I've got the square root of 53 for this side. So this length is the square root of 53, this length is the square root of 53, and this length is the square root of 50. therefore two of the lengths are the same, I've got an isosceles triangle. And that's the answer to the question.